Okay. And there's another PD that's going to kind of make their way in and out. I think there's going to be students on campus and middle school teachers and high school teachers all combined. It's going to be a busy day. Okay, we're trying to explain why balloons explode with so much energy when they're filled with hydrogen and oxygen gas. As an interaction teacher, you might not want to do hydrogen and oxygen gas balloons. Okay, I used to do this experiment with a Pringles can that was empty, and it was upside down with a little hole on the side, and I would fill the Pringles can with hydrogen and oxygen gas, and then you would take a yardstick and you would light it, and the Pringles can would hit the ceiling. Okay, pretty interesting. The drawback to a Pringles can filled with gas is that you're just letting that gas fill the classroom. And I've accidentally lit the gas when it wasn't supposed to. And I believe my thumb was over the can, and there was like a spark or a flame, and it just ignited, and then just like knocked my hand, and a huge bruise on my thumb. So I'm going to show you an alternative to a hydrogen and oxygen balloon that's going to be exploded. We're going to use soap. Now soap it's flexible, it's soft, it's safe, but it's going to be very loud. So who brought their earplugs? Raise your hand. Who brought their earplugs? Okay, all right. There's earplugs here.
Kids probably like that.
Not my.
Oh, they love it. They love it. So
not
goggles.
Not the kids. They don't like the loud noises.
Okay, so maybe a video
I'll show
clip.
them the video. Yeah.
The video clip might be helpful. So earplugs will go around when it's time to light the soap. So I will be doing it, and you could watch from where you're at, or you can come closer. Actually, I think when I make the gases, I'm gonna have everyone watch, and then when I light the bubbles, you can stand at the distance you feel safe at. And I'll be wearing these. These are electronic, so I can hear what you say. But with your earplugs, you might not hear what I say. But you can still ask your questions, and I can still lead you into some clarity and understanding. Okay, so carbon dioxide gas is going to put out the match when I make the gas and I fill it in here. The oxygen gas is going to go in this test tube. When I light a match and I put it in, it should glow brighter. Sometimes it's hard to tell, so a glowing splint test would be better, which is when you light a match and you blow it out, and then that glowing ember is what you put in the oxygen, and that will glow brighter. And then the last is hydrogen gas. And hydrogen gas, when you take a match and you put it over the opening, it's going to make like a pop sound. Okay, a pop sound. Can't snap with gloves, but you know what I mean. So that'll be the first thing you do in Unit 2, Part 2, Investigation 3. The students are going to explain why these are different gases. And as an adult, you might be able to reason immediately, okay, this one put out the match, this one made a glowing splint brighter, and this one made a pop sound. And so the students have to acknowledge that all three gases are colorless and clear, and you cannot tell the difference until you do a flame test and a glowing splint test. And that gets students interested in what are things made of, and why do they have different amounts of energy. Okay? And then a few weeks later, they'll be able to put into words why balloons filled with different gases will have so much more energy than a balloon with air. After I show you, after I demonstrate the ways to make different gases, I'm going to combine whatever I have left over in hydrogen and oxygen, and then light it. I'll also light whatever I have left over with just oxygen, and whatever I have left over with just hydrogen, so you can get a comparison. And that'll be the anchoring phenomenon for Unit 2, well, Investigation 3 and 4. After you show your students a video clip or do this activity, the students are going to do a hands-on activity where they take a battery and split water into two gases called electrolysis. Has anyone ever done that? All right, how'd it go?
They loved it.
They loved it.
I did it last. I haven't done it yet. I did
Yeah.
it last year, and
Okay.
it was like their favorite activity.
It was their favorite activity. It's probably one of the most sophisticated hands-on activity in interactions. So if you're in Unit 1, yes, they work with tape and rods and fur and balloons, and it's wonderful. It really builds a foundation. But when you get to Unit 2, that's when the students get to like blow stuff up, and that's what they want to do. I've never met a student that didn't want to blow something up. I think everybody wants to blow something up. Just not hurt anybody, but blow something up. It's fun. That's why 4th of July is so wonderful. So, so Emily's had success in her class by having the students split water into two different gases. So on your tables, there are kits. I really wish you could just do your own today, but IHAM does want the videographer, photographer seeing you work in pairs. And so,
You need to work in pairs, right, to be able to like. hold that.
and it's actually easier to work in pairs. Yes, it's cumbersome if you work by yourself. And so when you make your own gases at your table, your test tubes won't be this size, they will be this size. So the students will have a more manageable amount of gas when they collect it from water. And then you have a lighter, and you have wooden splints that you will light or make glow, and you'll stick it in your own test tubes, and the students will see, wait a second, water doesn't make popping sounds when it is touching fire. Water doesn't make glowing splints brighter, but when water is split, it acts differently, it has different chemical properties. So students start to really understand, okay, things can look, the way they do, but if you, add electricity to it or add a flame to it, it's going to do something different. And it's very clear in interactions. And so, so you'll be doing that around 9:15. Okay, so 9 o'clock, I'll blow stuff up here. Around 9:15, you're going to make your gases. But it takes about 45 minutes to get enough gas to light. So you'll set it up, you'll make the gas, and then around 10 o'clock, you will take your tubes out. It's preferable to have corks that fit this. That way, when you take it out of your cup of water, the gases won't leak, but you can still use your thumbs. It still will work. But corks are preferable. If this was the school I work at, I would definitely have corks for you. I'll have to edit that out. But you know what I mean. So you put your thumbs in, go like this, and then you take your flame, put it over, put your glowing splint, put it over, right? And as an interaction teacher, / chemistry teacher, I'm going to show you how to set this up. So it's more efficient. It's so helpful to pre-label everything. Because if students have just glass tubes, they're not going to know which one's oxygen, which one's hydrogen. Or they'll swap the two and they'll think, oh, this one's hydrogen, this one's oxygen. And then you'll have conflicting data. Or the students will put the battery positive and negative where it's not positive and negative. It's the other way around. So they'll confuse themselves without even knowing it. And so that's probably one of the biggest challenges of interactions is if you do a hands-on activity, the students could accidentally tamper with certain parts or misread something, and now you have conflicting evidence. So the videos in the trail guide, right here, the YouTube video recorded activities, this could be your saving grace. It saved me so many times. Even though I did the experiment at home, or I did it in class and I recorded it, it's still evidence that the students can form consensus around. Otherwise, students will be like, I'm lost, I don't understand. The positive gave me a different gas than the class is getting. And then it's no longer about learning why things explode, it's like, why am I the student who always, gets something wrong? Or, what mistakes did I make? And why is everyone else doing better than me? And that's an awful feeling. I've had that feeling in high school and in college too. And as adults, we always go through those types of challenges also. All right, so it's 8:35. Let's start setting up the carbon dioxide gas first. So if you could stand and crowd around. And the trick to this, not the trick, but a suggestion I have for carbon dioxide gas formation is you'll need at least 2 buckets of supplies. So one is going to be filled with water, and the other one is going to have calcium carbonate and acid. So I'm going to grab my calcium carbonate really quick. And let's put this up here. And just so if you have a sink in your classroom, so much easier than bringing your own water. But this water is going to be better for your students' hands-on activities, because I've taught at 2 different schools, and whatever's in the plumbing, okay, whatever's in the water can actually grow like algae in the test tubes. Because when you produce oxygen gas, algae feeds off of that. So students would get oxygen gas, but they would get also a green like slime that wasn't there before. They're like, oh wow, what did this come out of water? And I'd say, yeah, LAUSD water, you know. But if we use distilled water, nothing will grow. So it's best to use distilled water for the student activity. And as a teacher, when you're making carbon dioxide, you don't have to, because algae doesn't grow from carbon dioxide. All right, so let me poke a hole in this. Some scissors. Yes. We're going to dispense some water into a bucket, and then we'll reuse this water for your hands-on activity. So water is so useful for collecting gas because it'll trap gas in a container when you fill it and hold it upside down. So if you have a sink, so much easier. But if you are in a library, definitely use a bucket. And I'm actually gonna pray this doesn't leak because I haven't tested this bucket. I drove from Gardena with supplies that I acquired, and this is a brand new bucket, so it should be fine. Okay. So we need just enough so that this test tube for carbon dioxide, okay, I'm gonna put it here when I'm done. This was supposed to be carbon dioxide, but I didn't have time for labeling. But we can remember this together.
I'm in alphabetical order.
We have a little chip, so I'm gonna be careful. All right. Yeah, alphabetical order. Carbon dioxide, hydrogen, oxygen. All right, so got my cork, got my test tube of water. What I'm gonna do is hold this upside down. Carbon dioxide will be forming in this tube. And then I'm gonna stick this in the tube, and the carbon dioxide is gonna push the water out. And then I can trap the carbon dioxide in by placing the cork back inside without losing it. Is this showing on the video recording?
Yes.
Okay,
Is
wonderful.
there already carbon dioxide in that?
There isn't. We're gonna make it with calcium carbonate
Okay.
and a little bit of acid. So do all of you have chemistry teachers at your school? Yes. So it requires very little, not ingredients, but compounds. Maybe like a couple spoonfuls of this, and then the acid is a 6 molar acid. I definitely recommend using goggles and gloves if you're the one handling the materials. This can also be done before class starts or the day before. Carbon dioxide stores really well. Probably best if you do it the day before so you can take your time, especially if you're using acid. So I'm gonna put calcium carbonate in this flask and the acid. It's gonna bubble up. It's gonna force the gas into this test tube, pushing water out. I'm gonna recork it, and then I'm gonna put it in alphabetical order right here. And then, and that's what you'll do as a teacher. And then when the students are in your classroom, we'll light a stick and we'll place it inside, and the students will observe how the flame goes out. Okay. All right. So this is carbon dioxide. Next is hydrogen. However, I want hydrogen to kind of be saved up for the last step, because we're going to actually use a stronger acid to make hydrogen gas. So I'm going to, even though they look alike, I'm going to go like this. And we're going to make oxygen gas next. Okay? So let's do carbon dioxide first, and then we'll get rid of my carbon dioxide stuff so we don't accidentally mix things together and then lose track. I want my own paper towels in case we have spills. In fact, I'm going to save some paper towels for you guys. Could you put like 6 paper towels in each bucket?
Sure.
Thank you so much. I gave you way too many, but you have enough. All right, so this will go under here. Let me get this out of the way. Extra gloves. Extra gloves. And one more thing. When your students made oxygen gas, did they make enough so that the splint would glow? Was it like obvious?
There's way more hydrogen than oxygen,
Mhm.
and I cannot remember. I remember just the oxygen being very little.
Okay.
Yeah.
So maybe they didn't all get to see a glowing splint.
Yeah, I don't think it got brighter.
Okay. So so as a teacher, it's good to have backup oxygen test tubes. And so after I make carbon dioxide, we're going to make oxygen gas using hydrogen peroxide and magnesium dioxide. Okay? Excuse me. And that's going to make a ton of oxygen. Thank you so much. So all I explained was that when you make your carbon dioxide, all you need is one big test tube. But when you make your oxygen, make one big test tube of that, but also however many lab groups of oxygen gas you might need for the students. Because when the students make their own oxygen, it's not really enough. I might have had one time when there was enough for the glowing splint to glow brighter, but after that it's frustrating because students want to see, oh, one tube made a pop. What does the other tube do? Oh, nothing? Oh, that's not important. That must not have been important at all. But if you can show them this tube has enough oxygen to so you can tell the difference, then they can use that information to understand why things explode. Okay?
It was also cool because it's H2O, so you're able to show oh, we have more hydrogen because there's more hydrogen than there is oxygen.
Excellent. Yes. So when the students see twice as much hydrogen than oxygen, then some will say, oh, H2O, twice as much hydrogen than oxygen. Thank you for that. And it's very visual, as long as they didn't lose any from their removal from the water. So carbon dioxide, oxygen, and then hydrogen gas. So this is the part where you actually might feel apprehensive how to handle the acid for hydrogen gas. For the carbon dioxide, we used 6 molar concentration, and that's enough acid to maybe create like an irritation on your skin, and you can just flush it out with water and baking soda. For the hydrogen gas, you actually have to melt metal, and in our teacher guide, it has you use the same acid you did for carbon dioxide for hydrogen gas, but it takes a very long time. So as a teacher who might have limited time to make hydrogen gas, you should use a stronger acid. And the legal limit of acid concentration as a science teacher is 12 molar, and it does go through bone. It does go through metal coins, so you have to be very careful when you work with it. Rubber gloves, nitrile gloves will protect you. Acids don't dissolve rubber or plastic, so you will be safe. I was so nervous doing it for my first time because I don't want it to splash. I don't want it to spill. I love my hands and fingers. I don't want to have missing parts. So, and it's not immediate. It's not like in the movies Alien where you spill a little 12 molar acid and it just goes right through. It would take hours and hours. But it is like annoying if it is on your skin because it'll itch, and then you just, you feel like, oh, I'm gonna lose my fingers. But it's just a very, very, very slow burn if you get a drop on you.
Can you just wash it off? Or
You can wash some of it off, but it's already kind of bonding to your skin. So you have to use baking soda and water because baking soda will neutralize the acid more than soap. And so that is that's the disclaimer about 12.
baking soda.
Yeah, have baking soda ready and water, and then you just keep adding it to your to the area that's been affected. So I just wanted to give you all fair warning. There are video clips how I did this with 12 molar acid, so you don't have to. You can show the video clip if you'd like, or if you like to buy your chemistry teacher a coffee and just say, hey, could you help me make hydrogen gas? And they will most definitely say yes, because chemistry teachers are a little cuckoo because they want to blow stuff up and they want to melt things. So they should be inclined to help you make hydrogen gas. And I'll walk you through the steps as well. So that's going to be in my hydrogen bucket. Right here, this is an oxygen bucket. This is my hydrogen gas bucket. And then we'll collect it in here, but then we'll immediately get into the soap bubble before my hydrogen gas runs out. We'll make soap bubbles of oxygen, hydrogen. I'll burn both, proving to you that they're both different properties. They have different chemical properties. Then we'll combine the bubbles, and then my ice scoop. My wife let me borrow her ice scoop. She loves her ice machine. I will scoop up a few hydrogen bubbles and a few oxygen bubbles, and then light them, and then you'll get a nice big bang. We'll do it a couple times, but I'm not gonna do the whole bucket because that could be more than our earplugs can handle. Okay? And if you feel more comfortable, maybe you can do it outside, but this is a lot to carry outside and then bring back in. So we'll just do a little bit inside. And I've done this inside in a classroom with students, and they weren't wearing earplugs. I think it's preferable if you provide them with earplugs, but they didn't say that the sound hurt. There was no complaints. They actually wanted me to do it again and again and again. So maybe because we're older, our ears are more sensitive. Unfortunately, that's why earplugs are provided to you. Okay. All right, so let's go ahead and start with the calcium carbonate and the 6 molar acid, which is over here. And zinc, carbonate. Oh, it's in the box that says corrosive. So this is the acid that is a weaker concentration. So this one, I don't want you to feel apprehensive about because it is not as strong as the 12 molar. It's good they have this tape so it doesn't evaporate. I'll try to keep this to be reused. All right, so calcium carbonate. So we're just making one test tube full. So I already took too much. All right. Get a little more. And then you can always add more when you feel that it's needed. But we'll start with that much. About 2, let's say a tablespoon. We're gonna go with measurements. pour this into our flask. And it should dissolve immediately. All right, carbon dioxide gas. That's an interesting color. Okay, I'm gonna set this aside. Place this here. And it looks like we need to add some more. Let me add some more. I am surprised it turned green, but that might mean because my flask wasn't completely clean and dry as I might want it to be. But we're not trying to get a pure solution, we're trying to get a gas, so it's fine. A little bit more.
How do you know that you need more?
The bubbles stopped.
Oh.
Alright, there we go. Got my test tube ready. And I'm gonna push out the water using carbon dioxide gas. I'm surprised that this is longer than usual. Maybe because the powder is so fine, it is taking longer than expected. You can definitely do this one-handed. Might be a slight spill. Oh, of course. Let's capture it.
Oh, wow.
Okay, so that was sufficient. I'm gonna take this out and capture it with the cork. And I'm glad I'm wearing gloves because that sharp edge was poking my skin a little bit. Okay, I'm gonna dry my gloves off. So that was probably what, like 4 tablespoons? Because it's a fine granular calcium carbonate. You can get calcium carbonate in larger quantities or larger sizes, mossy calcium carbonate, but it was enough to get our job done. Okay, let's set this aside so we don't accidentally mix our, that's my bucket. Let's put this in my green bucket.
So when you use this,
Calc-
the beaker,
The test tube,
test tube?
yes.
when you put it in, was this tube
In the water.
in the water, but
Yeah.
you put the test tube like
So
next
this,
to it, or
so,
it didn't matter
so,
where
so this is filled with water, right?
Uh-huh.
And it stays filled with water as long as it's underwater. And then when I place this tube
Oh, okay, so-
inside,
oh, okay, so you place the tube inside.
when I put the place tube
Oh.
inside, it pushes all the water out
Mhm.
because it's filling with the new gas.
Okay.
Yeah, and it's called water collection, gas collection over water, and it's
So then when you take out this tube,
when I take it out.
yeah, when you take it out of
Yes.
you're underwater, and
Yeah.
then do you put your thumb?
I put the cork in.
Okay.
The cork was in the water,
Mhm.
so I was able to,
Just like slide
Trap
like
it.
that. Okay. Okay.
but I didn't lift the tube so that the opening's facing up because all the gas would come out.
Mm.
And it takes some practice. So, but it's very satisfying once you get it done because it's like, oh, I just made gas
Mm.
from nothing, right? from something, and so it's
Cool.
you'll love it once you try it. Okay, so let's set this aside. Carbon dioxide gas. I might reuse this cork because the other corks are a little slightly different than the others, but that is something I might use later.
And you can just pour that down the sink.
So
Good question.
so whenever you use acid, it's kind of, you don't know exactly how strong it is afterwards. This should be neutral. This should be close to neutral. You can test it with paper or indicator to see if it is still acidic. But all chemicals should be placed in a container for your chemical safety person at your school.
Okay.
So usually it's the chemistry teacher or science department chair. So you can label it and let them call it in for pickup. So that is carbon dioxide gas. I'm gonna set this over here, out of the way, and we're gonna make oxygen gas now. And we'll use the same tub because it doesn't matter what really is in our liquid because the gas is the priority. So let me get my oxygen bucket, and let's put this acid away as well. That's as good as it gets. I'm going to add this to my carbon dioxide bucket. And what we have here is hydrogen peroxide. It's the same household chemical for your wounds and for bleaching hair. And then magnesium dioxide would, this would react with hydrogen peroxide to make oxygen gas. Okay? And what's nice about magnesium dioxide is that it's reusable. So when you're done, so this is left over from like last semester. Once you mix the two together, it makes tons of oxygen gas. I'm gonna fill up this test tube with oxygen gas and these so we can test the glowing splint with oxygen. And then when I'm done, with today's PD, I'm just gonna let this air dry, and it's just gonna be this magnesium oxide powder again. So it's really economical to have magnesium dioxide, and most high schools will have this in their stock rooms. So let's go ahead and pour that in. Oh, let's prepare our test tubes first by filling them with water, so we can trap them with water. I'll go ahead and do that with my other test tube, so I'm one step ahead. And if you teach multiple classes of interactions, then you could have as many test tubes as you want, because the amount of gas produced is going to be filling them up even faster than the carbon dioxide. Okay, so let's test this stopper with magnesium dioxide. Make sure my hands are dry, my gloves are dry.
Would it ruin it if it got wet?
I think it might slow it down a little bit, but magnesium dioxide, it'll just like dilute the hydrogen peroxide. So we'll go with a tablespoon or two, and then pour the hydrogen peroxide in. It's good to have a bucket to collect. It's good to have a funnel if you have time to prepare that. But this is a very benign compound. It's not going to, it's not toxic. That's what I meant to say. Non-toxic. Okay. So maybe like a tablespoon and a half. And then we can always add more if we need to. I wish it was a cleaner pour, I'm sorry. So you can do this with bread yeast as well, but it's extremely messy, and you can't reuse bread yeast with the hydrogen peroxide. All right, so it's bubbling. I'm going to take off the cork. If you want to take a look closer, so the cork is blocking the water from leaving. So I'm going to remove the cork, and then I'm going to place the tube inside, and then I lift. You see how the tube's inside? And then I lift it up, and it's gonna push the water out. And if it slows down, I could just stir this a little bit like that. And then it continually pumps the water out. And then I can remove the tube, and then stick the cork on without lifting the tube too high. So now we got oxygen gas. We're gonna repeat that with these test tubes for the class set. I brought my own corks, so we can use these to plug the test tubes. It would have been nice for every kit on your tables to have corks, but it's not a perfect system when you order supplies and they haven't delivered and something's missing. Okay, so it looks like my oxygen is still going, so I'm gonna salvage what I have and stick the tube in the test tube. And I'll shake this a little bit to speed it up. Oh, my cork's loose, so that would help to keep it on. It's slowing down a little bit. All right, so I'm gonna trap what I do have, and I'm gonna add more of both so we can speed up the process.
And in the stores, there's like different hydrogen peroxides, right? Like,
Yes, so this is the 3%, which is really safe to use and very inexpensive. This is like $1 for this much. And then if you want stronger ones, sometimes you need kind of a license or a clearance to purchase it. But you can also do an experiment called elephant toothpaste if you're able to get your hands on a really strong hydrogen peroxide. But that's non-interactions related. So we'll have to edit that out of the video. Alright, so let's go where I left off. This one. So tube goes in, pushes the,
Oh, that's going quick.
yeah, it goes a lot faster when it's fresh. I'm gonna put them in here so I don't accidentally double my amounts of oxygen.
I think it'd be cool to show the kids how you did it. But it
Yes.
takes a while.
It takes a while, and you have to watch everybody.
Yeah,
It's
yeah.
that's the only
Yeah.
drawback. Because this is like the science that really teaches you about, how to handle the materials and equipment.
Maybe have them like start like taking notes or something so they could be busy a little bit. Or draw
Yes.
a diagram or something while you're doing that stuff, I guess.
Yes,
Or something like that, like, because you're gonna have to be concentrated on that.
yes, especially when you so this oxygen gathering collection it's pretty safe. So it would be okay if students started to try this out. But for sake of time, I'm gonna be doing this for you guys because of we have so many more things to do after this. But that is our oxygen and carbon dioxide collection. Okay. Oh, there's one more. And it does get warm. This chemical reaction in particular releases some heat, but it's not.
You could tell it's
Alarming.
like steaming, right? A little bit, like the steam.
Yes. So Caesar's referring to the walls
Yeah,
of the
yeah.
flask. So whatever water that's being produced from the mixture, it's starting to become vapor. So that is a very astute observation. All right, so oxygen is going to be produced. I'm gonna add some soap to this so we can use it for our explosion. I'm gonna need more space, so I'm gonna apologize later to this librarian and scoot his or her stuff over. Looks like that's taped. Hello. Oh, thank you. So this is for teachers only. You'll have to find where the students are at. Sorry. But there is a student program on campus. Poor kid. Okay, so we're gonna make a bucket of oxygen soap bubbles. I'm gonna make this bucket, it has some water in it. Stole this from the restroom, sink. It's gonna be a like a water bath that keeps this kind of cool. Okay, so I'm gonna leave that in there. And then this has some magnesium in it, but that's okay. That's fine, because we're just gonna add water to it, and it's going to make soap bubbles. And then this one is gonna be our mixture of hydrogen and oxygen gas bubbles. So this is for my hydrogen. So it's carbon dioxide, and that is gonna be my hydrogen. And then this bucket will be for my hydrogen gas, red for danger, I guess. We can remember it that way. I'll scoop this over. My soap is in here. So it was kind of fun packing up for this, day, because I got to like label all these buckets. Oh, oxygen gas, carbon dioxide gas, hydrogen gas. Felt like I was working for the military or something, or a chemical company. Okay, so here's our dish soap that we'll make oxygen gas for. And then here's our dish soap for when we combine the two. And then we'll have a bucket for hydrogen only. I'm gonna scoot these over. Okay, we're right on schedule. First, I need to collect hydrogen gas in here. And I'm gonna need some more water. So I'm gonna fill this up. And during the break, I think we'll have enough magnesium and hydrogen for all of you to practice filling test tubes with gas. The one that doesn't use acid. That should be good. Okay, let's get the earplugs out. Pass them around, please. And then you can keep these earplugs, of course. Okay, so don't put them in yet. Not yet.
I could hear you.
Okay. Yeah, if you can hear me, that's great. Just in case you forget, but I'll remember to remind you. Okay, so earplugs, but that's when we mix the gases. Right now I'm just gonna make hydrogen by itself to put in here. And then I will set this aside for our, for the demonstration teachers have to do for investigation 3. And then we'll do the explosion. So when you teach this in class, I wouldn't go in this exact order where you make these tubes and then you do the explosion. This is gonna be a separate day. It's gonna be a separate day. And then this will be a separate day. So 2 days of blowing things up. Okay? All right, let's make our hydrogen gas. So zinc metal. And zinc can come in a powder form or this mossy form, which means they're chunks. And it would have been nice if the calcium carbonate that was in our carbon dioxide mixture, if that came in chunks as well. It just dissolved so fast I had to keep adding it. So try to get mossy zinc. And I think, okay, and there's an order you want to do this. You want to put the acid first, because when you put this metal first and you put the acid on top, it's going to bubble, and there is a slight risk that the bubbles can start splashing out. So acid first. This is the 12 molar acid. It actually has a strong smell, so I'm going to try to pour and then cap it so you don't feel the fumes. already feel the fumes.
Yeah.
Okay. Okay. I'm going to set this aside. And let's add our metal. And I will grab more if needed. It will get hot, so I'm going to put it in the It's hard to see with all the smoke. Okay, I need to add more water. I keep emptying out the test tube when I lift it up. Let's try that one more time. There we go. Shake it a little bit. Get some more gas. Okay, I think I need to add more metal. So I'm going to cap what I do have and then add more metal. Dry my hands off. And I am going to plan a little bit ahead. Let's put this away. Okay, so I have a half test tube of hydrogen gas, a little less than half. I'm going to make more gas, and it's going to empty this out, and I'll put this on the rack. Then carefully, but also not too slowly, I'm going to make oxygen gas, and it's going to be bubbles of oxygen gas here. A property of oxygen gas is that it will make a glowing splint brighter. So I'm going to light this paper towel, and I'm just going to put it in the oxygen gas bubbles, and it should get brighter. In fact, let's do that first, because we can always make more of this. If I didn't have to borrow the acid from the teacher upstairs, we would just do both. We would do this, that, and then we would combine. But I have to save our acid and our zinc for the oxygen gas bubbles. So let's do this test first. Let's add more peroxide. My Dawn dish soap. Let's go like this so you can see better. So I'm just trying to jostle this liquid so that it'll produce gas. I'm gonna light my splint. So I'm just lighting the paper towel. Okay, so it's glowing splint. So dish soap should not make flames brighter. Dish soap should go out when it hits flames. Here, let me cool this off. we'll try one more glowing splint. My glowing splint didn't have as much ember as I wanted it to. Let's see if we can make it a little brighter, especially since we have excess oxygen being produced. Set this aside. Let's try it with the stick. 2 sticks. So much easier than paper towel. You see how it relights when it touches the soap bubbles. So that's a property of oxygen. No other gas will do that on our table. Okay, so oxygen is being made. Now let's make our hydrogen. We'll combine the two, and then are your earplugs in?
Oh, no.
Yeah, let's put your earplugs in, and then we'll have a nice explosion that will that normally wouldn't happen if you didn't have the energy of the two gases. So there's my acid.
Do you need soap in that one or no?
I'm going to open it, but I'm going to wait for it to produce. Keep this right side up. Stick it in the tube. There we go. Ample hydrogen gas. Sorry for the odor. All right, now we're going to place this in the... I have to make soap bubbles from the hydrogen. That's going really well. So I'm going to now add oxygen bubbles to this middle bucket. Let's add a few more spoonfuls of magnesium oxide. Guess we have enough to just scoop it from here. And we want twice as much hydrogen than oxygen. So here's my hydrogen gas. Here's my oxygen gas. Are you ready? Okay, let's get more oxygen gas. In fact, let's combine it. Combine the two. It was hard to tell which one's oxygen, which one's hydrogen. So we will make bubbles of oxygen and then combine them with hydrogen. It's a race against the hydrogen. Twice as much. Left-handed. Let's consider what's happening. Hydrogen gas being made, oxygen gas. Maybe we'll do this to make it a pure mixture. I'm a little nervous with this one. Pop. I think we need to add more dish soap. Not soapy enough. Okay, so a little more energy there. We'll keep going till we get a nice, satisfying pop. Okay, well, that was kind of poppy, right? But not as loud as I wanted it to. I still have acid, and I still have metal, and plenty of magnesium oxide. So let me stir this up so that it gets more evenly mixed with the soap. And then we'll make a larger pile of soap bubbles. I feel like I'm raising the stakes more and more, but hey, we're here, right? We've got our earplugs. And thankfully, we don't have more witnesses or a larger audience. It would be extremely hard to manage, but you guys are a great PD group. Okay, I'm gonna get more acid, and I'm going to maximize the production rate of both gases so we can have a more satisfying explosion. Okay. Hello.
Hi. Okay, this is not for Missa.
Yeah, this is science teacher PD.
Oh, okay.
Yeah.
Cool. Thanks.
All right, I'm gonna add acid to this one. This one's slowing down. And then I will add oxygen gas. It's still going. What about this one? This one is slowing down too. I wonder if the distilled water is not making my water as bubbly with soap as I would want, but that's still in question. Let me try one more time.
Why do you want twice as much hydrogen?
So the result of the two gases will make water, H2O. But when you have that ratio exact, the energy that is released from the formation of water is so high. It's so high because right now the energy is stored in these bonds and these bonds. But as soon as water forms, it's going to release energy into the air and no longer store it. Okay, I see a lot of hydrogen bubbles here. I'm loving that. So let's see if I can scoop a nice amount for each. What also could be the issue is that the scoop is starting to pop the bubbles faster than I want. So what I did in my class was I made this like a tray where I put the bubbles on top, and then they did not pop as fast as they would in the scoop. So let's make a nice little tray, and I'll pop it from the tray. I'm so glad the hydrogen is really productive. We just need more oxygen bubbles in the mix. Slowing down, let's add more peroxide. I'm just going to do this. I'm going to put a pile of bubbles on this tray, and then we'll light those bubbles. Just bear with me. Thank you for your patience, everyone. He does not look happy. My oxygen bubbles are not forming. Let's try this solution instead, because I think we did pretty well with this solution. Yes, this is more of a conducive solution for bubbles. very weak. Let's get some more. Perhaps we'll do oxygen first and then hydrogen on top. After this, we'll definitely take a break. Okay, so now that one's slowing down. Let's add zinc before we have more acid added. Oxygen's really cooking. So whatever was in this bucket, it's not letting bubbles do what bubbles are doing here. This one is definitely producing more. A little more soap. Let's do oxygen first and then hydrogen second. I was hoping that was the ratio needed. Okay, we'll do one more, and then we'll just watch the video. What should have happened, and then I will troubleshoot throughout the day why this is not the bang I wanted us to have. Okay, we'll do hydrogen first this time. I wish it would slide easier off the scoop. Be more careful. Okay. I'm gonna have to revisit this. Let me show you what can happen when conditions are ideal. I apologize, everybody. You can take your earplugs
cool.
off. You'll probably hear a random explosion when I finally get this to produce. Okay, so I'm gonna go to the trail guide and click on YouTube recorded videos. And this will be under the playlist 2, 3, 1. So right here. And we will use that's what we're going to do together. Testing gases, whoosh bottle, hydrogen, maybe it's in 2.4. My teacher account, maybe that was the issue.
My name is Rachel Nelson.
Let's go here. Here, 2.4. Okay. So this is the edited version where it's a lot faster.
Does oxygen?
Oh, you're in.
Let's make this.
Does oxygen?
Oh, you're in.
Alright. And this is hydrogen gas.
Okay.
I think we can actually do that right now. We have enough hydrogen gas here. Everyone hear that?
Mhm.
Okay, so that's your hydrogen gas. What a waste, but we'll continue. Alright, see how sudden that was? So to get that type of reaction, your bubbles have to be just really stable instead of. I want to try it again. Do you guys have your earplugs still? Okay, can we try one more time? our gases are just going. This encouraged me a little bit. Gonna put it on this tray. Maybe it's good to have a little solution on there so the bubbles can sit on something. So our hydrogen, beautiful hydrogen bubbles, and then our mediocre oxygen bubbles. They do pop when they land. Okay. We'll keep troubleshooting throughout the day.
What if you put the hydrogen bubbles in the oxygen bucket? So that oxygen doesn't pop.
Let's try. That was a little more. Let's just do this. And I'll just keep popping it. Any other ideas? I mean, they are popping a little more. It's less work to pop these this way. All right, well, we'll be back to the drawing board. As you saw the evidence, I was able to get it work in my classroom, but I will work on this as you take your 10-minute break, everybody. Take a nice 10-minute break.
Yeah, you weren't thinking about it. Yeah, it's Saturday. Just enjoy once in a while.
Together. A little bit better. Let's get a better.
Okay, so I can tell right away. Look how dark blue
I was
the.
gonna say, do you think there's not enough soap?
Not enough soap.
I think there's like a lot of water.
Too much water.
Yeah.
Okay, let's dump some of this into the sink, nearest sink. All right. Thank you for that. We'll keep working on this.
That's what I was thinking right now. I'm like, man, I think
The
like,
kids would love it. Yeah, then I have to go ask you the
yeah,
time.
you know, like I'm not there yet, and no way I don't think I'm gonna get there this year.
Oh,
But
really?
yeah, I'm barely gonna finish unit 1.
Oh.
So maybe for next year.
Yeah.
If I even teach this.
Exactly. This is where I'm at. This is like the next thing I'm gonna do. But I always go back. Yeah. No. You sure? Oh, really?
Like the, my AP wants to go lighter, like this.
that's why we're getting so many kids, because they don't wanna go for home inclusion, so they're pushing home.
Because parents don't.
Yeah, parents, so we have to have a conversation with government. Okay, like, you have the ultimate say. Principals trying to push for it.
What do you teach?
English and math, and this is first time in my life. I teach everything. Math, science.
The first year of teaching interactions, I was like, I was literally learning everything, I'm like, I don't know any of this
Yeah.
stuff, I'm like,
Yeah, I don't know science.
yeah.
I'm a music major.
The kids will ask me a question, I'm like, that's a great question, did you try looking it up?
Google it. Let's see
Yeah,
let's
let me
find
know what you find out.
We'll figure it out.